Good morning and welcome to this webinar on drones and specifically on the use of drones in farming. This is a sector which is constantly growing, also thanks to the evolution of agricultural mechanization with a goal towards greater efficiency and sustainability. My name is Jacopo Oldani of the magazine Macchine Trattori, which is sponsoring this webinar, together with the magazine DronEzine, which is a reference for the sector here in Italy. And today we have Stefano Orsi, the scientific director of the magazine. So welcome, Mr. Orsi. Good morning and thank you for the invitation. Then we also have Paolo Martelli, brand manager of Attiva, the Italian importer of the brand DJI, the technical sponsor of the meeting. So good morning also to you, Mr. Martelli. And he will focus on the practical use of the latest DJI technology in farming. Finally, but he will be the first speaker, engineer Alessio Bolognesi, technical head of Federunacoma. Good morning. Good morning. So we thank you for your participation. So, Mr. Bolognesi, drones are surely part of this transformation which is taking place in the field of farming mechanization, indicated with the term Farming 4.0. Where are we today with the introduction of these new technologies? They are a fundamental component of this digitalization process. This is true at 360 degrees. I must say that they're perhaps one of the main tools that we have for the so-called remote sensing of our fields. We know very well that we can install on drones a series of sensors, of different cameras that allow to carry out analysis with different spectrums of light, so as to analyze, the soil as well as the plant. And of course, the agronomic evidence is then used for the programming of treatments, of processing, or to assess plant health. So this is the use which today is more common. This said, we have also a series of new or pseudo-new frontiers which are opening up, including the use of drones for targeted treatments, all the way to the use of drones as a support, as a radio bridge to bring connectivity to areas where the connectivity is absent, or they can be used to coordinate the activity of autonomous machines. Now, there are some solutions that have already been implemented, while there are other new frontiers which are opening up and which are being developed. Now, clearly, this concept is based a bit on the topic of agriculture 4.0, and we got to this stage without actually defining what the 2.0 or 3.0 stages were. So everything happened very rapidly, also because of the evolution of the digital technology in the industrial sector. And so we now passed from the traditional combustion engine machines to the use of electric machinery, electric equipment. Then in the 90s and in the years 2000, we saw a turning point with the advent of connectivity between tractors and equipment, thanks to isobus. Then we started with navigation system with the GPS, and then we developed the sensors, remote connectivity, and drones. To say that over the last 5-10 years, we have started to have the establishment of these new technologies. As for the sector of agricultural mechanization and the use of drones, This fits in within the European Green Deal. One of the goals is, apart from the management, of course, of the agricultural and food supply chain, but there's also that of environmental impact of treatments. And drones help us because it is one of the tools which allow us, as I was saying at the start, to analyze what the situation of the field is. The data can then be used for precision treatments, and for years we have been speaking about precision farming. Unfortunately, I must be honest, in Italy this is not that used, while outside of Italy there is surely a greater use of precision farming. And perhaps, I don't know why, but maybe in Italy we still have a problem in terms of our cultural approach. Because perhaps we still believe that the investment in new technology does not give us a financial and economic return, but it is not so. So this means that we have to generate evidence showing that the use of precision farming, of the 4.0 agriculture, does generate not only an environmental advantage, but it can generate also an economic advantage for the farmer. And so they can benefit directly from the use of such technology, which, I repeat, farmers usually don't consider. Now, however, the technology has evolved, and also this improves also pollution, which does improve also our life, apart from the financial return. Now, a series of actions must be implemented so as to allow the spread of such technology in our farms. And of course, I repeat, farmers and entrepreneurs, because we're speaking about entrepreneurs, they must, I repeat, change their approach. They must change their way of thinking. They should not just focus on the investment, but they should perceive the advantages which result from such a technology. This year, there's a plan that has been developed in Italy. It's called the Transition 4.0, which includes a tax credit tool which has favored the, so to say, use of 4.0 technology. It's just a first step, but it is already something which could, favor the future adoption of these new technologies. As I was saying, precision farming and the use of drones, or the use of drone in precision farming, falls within a specific scenario which requires the integration also with other technologies. So we should not think that precision agriculture is something which is too specific. No, it's something which is evolving and which implies the use of different technologies. So we need to do soil analysis, agronomic analysis done with advanced tool. We need programming based on the statistical and agronomic data. We need sensors. We need to program treatments based on the real scenario of the soil or field. We need machinery and tools that allow to work in a specific way. So we need also sensors that can identify in real time if and where we have to, for example, treat a specific plant or not. So we are dealing with an overall virtuous system in which drones play one of the key roles, but also because drones have a huge advantage. Well, first of all, because they can allow us to map the area by flying over it, and also they can host a series of sensors which may differ depending on the need. So with the same flying tool, so to say, with the same flying machine, we can in reality perform a broad series of analysis. And these can allow us to measure different states of the growth, for example, of my crop. So I can analyze the soil at the start, or I can analyze the state of health of my crop, or the level of humidity, the nutritional status. I can check if there is an infestation from pests, or if the color of a specific fruit, the apples in an apple orchard, are of the right red color or not. So from visual analysis to even the analysis of intrinsic characteristics of the plant. And indeed, we do have a series of sensors which can do this. They exploit either infrared light or in the spectrum of laser light. We can have stereo cameras, we can have thermal cameras to analyze temperature, etc. So you can easily understand. Now, I'm not an agronomist, I'm an electronic engineer, so I mostly focus on the technological application and not so much on the why we need a specific sensor to assess nutrients or not. But indeed, for those who have more skills than me on it, you can understand that we can do a series of targeted analysis. Then this is not all, of course. I represent the Italian Agricultural Machinery Manufacturers Federation, and so this analysis can be used also for our machinery. It can be used in forestry, it can be used for geological or hydrological assessments. It could even be used for the analysis and prevention of earthquakes. So there are many possible applications in which the use of drones and sensors is extremely important. And as I was mentioning, there are some restrictions, there are some limitations, but drones can be used also for specific treatments, especially, for example, if we think about organic agriculture. Well, at EIMA 2018, we saw the presentation of drones, which could, now I won't go into the details because I do not have the competence to do it, but they can release eggs of, I don't know, I think it was a larva, which nourishes itself of some plant pests. And so a natural approach to remove the infestation there where it was necessary to do so. And with a view of improving the environmental impact and improving our sustainability, this is important. Think about weed killing, for example, which is a polluting activity, and a timely treatment, a precision treatment is a must. And then again, I was mentioning the fact that there are also new scenarios. We have been working on autonomous machines. Many were presented at different exhibitions. The technology is practically mature. Often these machines, since they work in a coordinated way, so we need more machines on the same plot, so they have to communicate one with the other. They must be monitored to verify what they're doing. And very often, or let's say in various circumstances, let's say drones have been used for the monitoring of such machinery in a more or less automated way, with the intervention of human beings or using algorithms of artificial intelligence to assess how the machines are moving. And of course, some orders can be given to correct what the machines are doing. And finally, another solution, which seems simple but which is important, is to provide services there where, maybe because you're in the mountains, as an example, there where these services are not present. For example, I refer to the broadband connectivity to exchange data. This is one of the goals that we are focusing on here in Italy. And so also in this case, in various exhibitions, we saw drones that can act as a radio bridge. And it's extremely useful. Then if I can add a final comment, is that what is again perhaps still missing here in Italy as against other countries is the fact that we have to understand, allow me the term, we have to understand that these are not toys. These are an extremely powerful tool which can allow farming to progress. And again, I go back to what I was saying at the start. We have to change our mentality. We have to change our approach. Thank you, Mr. Bolognesi, who spoke on the use of drones within Farming 4.0. For those who want to use drones, of course, they can do so in compliance with norms and regulations which have been developed over the years. To speak about this, we have engineer Stefano Orsi, scientific director of the magazine DronEzine. To the floor. Before focusing on the details of the regulation, which is quite complex and structured, the one that regulates the use of drones, also in the field of precision farming, I would first like to focus my attention on the activities which can be carried out with drones. The easiest one, and the first one, is to take aerial pictures, aerial photography, to map the territory. So the drone does a series of preset flights so as to take pictures which then will be overlapped one with the other, and we can digitally reconstruct the field. The second possibility of drones is that of verifying the health index of plants. This is something extremely useful, especially for agronomists, because it allows them to visually control, thanks to these multispectral pictures. We have a traditional picture which is overlapped with the pictures taken with different sensors, so they can assess the health status of plants. And we can have an immediate map saying that in that specific venue site, you have to give more water or you need more treatments. I'm sort of not an agronomist, so we're not going to the details of this, but it's easy to understand. Then another thing which is feasible legally is that of releasing some capsules which are biodegradable, containing a natural antagonist of corn's pyralid moth. So we have these capsules that are released by the drone. These open up and they can contrast that specific pest. Because the problem is, is that air spraying cannot be done with airplanes, with helicopters, not even with drones, because they've been compared to aircrafts since 2015. All this is true, but for example in France, and they're a bit ahead of us, they came out with an amendment in 2018, and so they have allowed to farmers with vineyards to spray if the slope is greater than 30%. Now, this is an amendment that lasts 3 years, if I'm not wrong, and so in 2021 they will also have to, either extend it or they will have to suspend that activity. But in the meantime, they have gained major experience with this technology. Drones have been compared to aircrafts, so let me come to regulations. Now, there are rumors on social networks, but also among the operators, that with the new European legislation, which should have been implemented in July of 2020, but then it was postponed to January of 2021, and probably with the pandemic, it will be postponed even further. But in any case, what has happened? Drones are now considered as aircrafts. So you cannot, I'm not saying going to the supermarket and buy one, because, okay, the ones that we use in farming are extremely specialized and they have been developed, for a specific use. So it's not that you can simply buy one and go on your field and use it. This is not possible, because as I was saying, there is European legislation, a world legislation, which specifies that to use a drone, you have to fulfill with a specific of norms. First, you need a pilot license, a flying license. And in Italy, you can get it online This is the basic license. It costs 31 euros in Italy. You just need a digital identity. You go into the website of the Aviation Authority and take the exam. As you know, in the past, it was much more expensive because with the regulations before July of 2020, imposed a basic course that costed from 6 to 7, 800, even 1,000, 1,500 euros, depending on the training center that organized such training courses. So the cost is very low. Theoretically, we have a license for non-critical use. And one may think that to use a drone on a field, the typical potato field or a corn field or whatever, one may think that this is a non-critical use. But in reality, the Aviation Authority abandoned the concept of air work, so meaning of professional operations, but they introduced the concept of a specialized or non-specialized operations. So for the non-critical use includes the recreational use as well as the non-specialized use of the drone. So personally, the suggestion that I can give you is that for all those who are interested, meaning farmers, agronomists, or whoever wants to use such drones, you should take a course and get a license also for critical operations. Because it is true that insurance-wise, maybe there is no risk if a drone falls on a field. Okay, maybe it can, damage a plant. But if someone does a control, well, that's a specialized activity. It's not done for recreational use. It's done for a specific purpose, and so you need a specific license. So my suggestion is to obtain both the online license as well as to go on with the training in a training center and get the license for critical operations. As of January 2021, when the regulation will be implemented, the European regulation, what's going to happen? Well, first, it's not going to be easy because of the COVID-19. You can see also from the mask that I'm wearing, there may be an additional postponement. Personally, I think that they could implement it even today because since March and until November, we've been living with COVID, and so we will have to get used to, going on via smart working. And also, the regulators, could go on with what they have to do. But let's imagine that there will be no postponement. Well, all the licenses, the basic and the critical ones that exist today will be converted. If you already have a license, you do not have to worry because you will be able to work also in the future. If you don't have it, well, then do what I was mentioning previously, because in the future, let's say, this is going to be the law. Among the prerequisites, as I was explaining previously, apart from having the pilot license, you need also an insurance. All drones, and this has been set by the legislation of the Aviation Authority, all drones must be insured, whichever their use. So this is another important step, and you cannot do without it. Another important issue is related to the areas where you can fly, the flying areas. We have to consider that before carrying out any specific activity in a specific field, well, first we have to verify if there are some limitations in that area, because it could be that in that area, maybe it's close to an airport, or it's a controlled flight area, the CTRs as they're called. And so maybe you cannot use the drone, or you can use the drones only within a certain height, because drones, at least currently with Italian legislation, which is equal to the European legislation, they can go to a maximum height of 120 meters. And from a technical and operational point of view, this is more than sufficient to carry out the work that I was mentioning previously. So to take pictures, to map the territory, while to release those antagonists that I mentioned, that's even too much, because you have to fly just a few meters, over the land. But this height of 120 meters may be limited if you're close to an airport, if you're close to a prison, if you're close to an institutional center. Even if it's difficult, but it may happen. Maybe you have a helipad in the area, or other areas for the takeoff of helicopters or airplanes. So before flying, you have to verify if you can fly in that area. To do so, ENAC, the aviation authority, has set up a portal which is called D-Flight. So you have to register. It's free of charge. You do not need to input any data of your insurance or license. You simply can verify if you can fly in a specific area. If instead you have to register your drone, which is also compulsory, you have to input the data such as the serial number, the brand of the drone, the technical data of the drone, and pay for the QR code, which is €6 for recreational use, which is not our case, or €96 for professional use. Again, on D-Flight, you also have to do a subscription, €24 for having access to additional services, which, apart from the maps of Italy, for example, it gives you other pieces of information. So they can tell you if in a specific area, for example, other people are using drones. Then you will also need a transponder. This should have been implemented as July the 1st. It has been postponed to January 1st, 2020. We do not know if the transponder will be implemented or not, because from a technical point of view, we still do not have precise indications. So also manufacturers, for the time being, do not know how to implement the law. So summarizing, the requisites, you need the pilot license, and I suggest that the basic one online, as well as the critical use one, which will then be converted into the European license as of 2021. You need an insurance, as mentioned, for your drone. You need the registration of the drone with the QR code. Do know that you're going to use it for work, so you Thank you, Mr. Orsi, for this analysis of the regulations. Let's now focus on these flying machines. We have Mr. Martelli, brand manager of Attiva, the importer of DJI drones in Italy, and they cover about 90% of the world market. I ask you, which are the products which are most suited to be used in farming? First, let's divide drones into 4 rotor drones, octa-rotor drones, or fixed-wing drones. I focus on this division because depending on the type of drone, you have different behaviors and different performances. I still have to mention the fixed-wing drones, even if in reality 4-rotor and octa-rotor drones are more common, but I mention them because fixed-wing drones can cover greater areas. This said, the market is favoring 4 or octa-rotor drones because the complexity of fixed-wing flights does not make it suitable for most farming operators. Focusing on the workflow which is necessary for the acquisition of data which can allow us to then intervene or to develop a specific strategy. Well, of course, to do this, we must follow a specific workflow. First, we need the mapping of the area. This can be more or less complex. You need at times also to position some markers. You have to take into consideration other variables such as the shade, the light, the weather conditions. You should also make some initial simulations which are necessary for the final mapping mission. Then you have to do the flight, taking all of the pictures, and then you have to align these pictures so as to generate 2D or 3D maps depending on your need. The software is extremely important, of course, and today there are, some softwares which are more used than others, and they are mostly the ones used by the professional operators. After the mapping, we have to take multispectral and RGB images. These must be mixed, so the data must be mixed. Why this? Well, because in defining our data to calculate the various vegetation indexes, we need both types. So we need the RGB as well as the multispectral images. What do we mean by multispectral image? It's a difficult term, perhaps unknown to most farmers, but known to agronomists. Well, each surface reflects light in a different way. So different surfaces reflect light differently, and they can give us information on the surface itself, but also on what is below the surface. The normal light spectrum can be split into the visible spectrum, visible with our normal eyesight, and this gives us information on the pigments of the leaves, so on the color, on the structure. Then there is a part between microwaves of visible light and visible light, which is called the near-infrared spectrum. So these waves give us information on the structure of cells. And then we have the short-wave infrared, which gives us information on the chemistry, on the content of water, on the biochemistry, on cellulose, on lignin, or to see the density of the forest. So we can simply take such data, and by analyzing such waves, we can have access to accurate information on the vegetation and on the crop that we're analyzing. Then in each farming season, the multispectral data can be used by farmers and by agronomists, because this supplies data which is invisible to the human eye, and they can be seen only via the electromagnetic spectrum. So having access to such data and having access to the vegetation index, such as, for example, the NDVI, so the farmers can take some timely decisions. By timely, I mean that you can take them when the problem is still at the start, when it is still limited, and especially it's an informed decision. So you can take decision based on sure data, sure information on where the problem is, on the size of the problem, and hence you can cut down costs, you can save a lot of resources, and you can maximize the future production of your crop. As for this first stage of the workflow, you should not imagine that this is something highly complex, going beyond the skills of a professional operator. And to this purpose, I want to show a video which shows you how easy this can be done.
In this video, we will show you how to conduct a mapping mission in GS Pro. Tap to select an RTK positioning method. Make sure the RTK is in fixed status. Tap the plus icon to create a new mission plan. Select the 3D map area to create a new mission. Select Tap to create a mission. Tap on the map to create a mission plan for the area you want to map. Drag the points to adjust the size of the area. Name the mission first. Set the shooting angle as course aligned in basic settings. In advanced settings, it is recommended to set the front overlap ratio to 80% and side overlap ratio to 70%. The flight speed will change as you adjust the overlap ratio. The course angle can be adjusted to reduce the flight paths for higher efficiency. Select the mission. check the parameter settings, tap Fly to check the status of the drone. When everything is ready, tap Start to Fly to begin the mission. Thank you for watching.
In this case, you have seen a Phantom 4 multispectral drone. This is a drone that has a special multispectral camera that allows to exploit the sensors to assess the health of crops, to assess the biomass, to assess forests, to map coasts, to assess vegetation and the ecosystem that we are interested in. As for the vegetation indices, there are 5 major sensors that can be used. We can assess the NDVI, which is the most commonly used to have information on the content of chlorophyll in plants. Then the GNDVI, which again focuses on chlorophyll, but it does so focusing on the spectrum of color green and not of color red. And for some cultures, for some crops, we have seen that the figure is more stable than the NDVI. Then we have other indices, I do not want to bore you, which assess the content of chlorophyll in crops as well as in sprouts, either at the beginning of the season, the CRI, or at the end of the season, the NDRI. And the last is the LSABI, which can be used to analyze the soil conditions. We know that plants are closely related to the biochemistry of the soil, and via this soil index we can verify some contents of the biochemistry of the soil, which can either damage or favor the crop growth. So with this drone, we have a multispectral integrated camera. The positioning of the drone is to the centimeter because it exploits the RTK network. So this means that we always know exactly where the drone is, and especially we can geolocalize all of the problems.
As the world population continues to grow, we need innovative ways to feed more people sustainably. That means leveraging intelligence in the agriculture industry to make operations smarter and more efficient. Meet the new tool that makes your workflow intelligent, the DJI P4 Multispectral. A high-precision multispectral drone solution designed to get you agricultural insights for targeted action. The P4 Multispectral retains the same powerful performance as DJI's other drones, integrating a multispectral imaging system that lets you see more than just visible light. Monitor crop health throughout growing seasons by generating vegetation index maps using multispectral images. Get accurate, consistent results thanks to the integrated spectral sunlight sensor that accounts for different levels of sunlight during different times of the day. Achieve centimeter-level precision with the RTK module and DJI's time sync system, allowing you to get accurate positioning data on both the RGB and multispectral images captured. DJI's iconic drone platforms have evolved for the world of work. The P4 Multispectral is an accessible tool you can rely on to collect plant-level intelligence for agricultural uses and beyond.
So in this video we have seen that the flight control allows users to pass from the preliminary assessment of the vegetation index of the NDVI to the RGB feeders, or pure visual data, and this can be done in real time so that we can visualize there where we need to focus our attention, so that decisions vis-à-vis a targeted treatment can be taken immediately and with great efficacy. There is a light sensor on the drone that captures solar irradiations and maximizes the accuracy of the data. This for any time of day. So if this is then added to the post-processed data, the indices that result are extremely precise. The sensors are calibrated so that they can work also for multi-drone missions, guaranteeing the consistency between data acquisition of the various drones. And what is all this for? Well, it can be used for targeted interventions and to do so at a lower cost as against what has been done to date. It's with pleasure that I want to show you now how we could use such drones once we have all the data available. And so we have the last video.
How can agricultural innovation be taken to the next level? A highly efficient, reliable, and intelligent tool is the key. This is the DJI Agris T16. The Agris T16 was designed from the ground up. It features 6 rotors, an RTK dual redundancy system, and an avionic redundancy system. It has a payload of up to 16 liters, a spray rate of up to 4.8 liters per minute, and 8 sprinklers work perfectly with the downward airflow, resulting in an impressive spraying effect. It has a spray width of 6.5 meters, which can cover an area of 10 hectares per hour. The multi-aircraft control mode functions with the FPV camera as well as an HD video transmission system with a range of up to 3 kilometers, ensuring flight safety and boosting spraying efficiency. Thanks to an all-new modular design of the T16, both the spray tank and batteries are easily swappable, which significantly improves operational efficiency. Its core module has a rating of IP67, making it easy for maintenance. The foldable aircraft arms are convenient for storage and transportation. A new battery management system and a 2600-watt 4-channel intelligent battery charger increase charging cycles by 100%. When flying in complex farmland environments, the onboard DBF imaging radar empowers the aircraft to fly over varying terrain intelligently. When encountering an obstacle, the T16 detects the obstacle's orientation and the distance to it, automatically planning a flight path to circumvent the obstacle. Pilots can view the live video feed and adjusted route on their remote controller. After circumventing the obstacle, the T16 will automatically resume spraying. To target unevenly distributed fruit trees and varying heights, the T16 comes equipped with intelligent solutions. With the Phantom 4 RTK, users can perform centimeter-level scanning of the orchard. Then, DJI Terra conducts 3D mapping of the scanned area. With its AI technology, Terra can also generate 3D flight paths for more efficient planning. With the help of the RTK centimeter-level positioning system, the T16 is capable of flying precisely along flight paths while accurately adjusting its spray rate according to tree distribution, reducing the pesticide dosage. The DJI Agris T16 delivers more efficient, reliable, and intelligent solutions, pushing the boundaries of crop protection. It lifts agricultural efficiency to new heights, opening more possibilities for the future of agriculture.
Thank you, Mr. Martelli, for this nice overview on the technology which is available for the sector. With this contribution, we come to an end, and I hope that this meeting may have contributed to a greater spread of drones in farming, and hence to favor the technological evolution of the sector. Thanks to all of you again for your participation, and I hope to be able to see you directly in the near future.